Hi jewelers, diamond and colorstone traders, consumers in this industry, as well as those who are doing the gemology courses. Let me welcome you to my YouTube channel, that is Universal Gems and Diamonds Expert, and I am your professional gemologist. Now today we are going to talk about the diamond which has a deep mantle origin. That means we are not going to talk about the regular diamonds which are available in the market. These are special diamonds. Let's call them as special diamonds. Before we start this topic, let me introduce ourselves as a professional gemological institute in Zaveri Bazaar, Mumbai, that is Universal Lab, and we provide reports for color stones, diamond grading, as well as the grading of studded diamonds in jewelry. We are also conducting courses on color stones identification, that is gemology, as well as in diamond grading. So coming to this topic, that is, these are special deep mantle diamonds, what we call type 2A diamonds. They are also known as clipper diamonds, that is CLIPPER, clipper diamonds. And before we start with this, I would like to tell you that if you see on the front page of this video, you can see that Mr. Ivan Smith, who's a geologist and who has done a lot of research in these type of diamonds, that is clipper diamonds, and along with him there's a Dr. Sally Magana, who has done a lot of research on synthetic diamonds. Now they are facilitating me with a certificate for advanced workshop on synthetic diamonds at GIA, that is Gemological Institute of America. So coming to this topic, that is diamonds from the great depth or from the deep mantle origin, type 2A. Starting with why they have been given this name, clipper. But before that, I would like to talk something about a normal diamonds which are available in the market. The majority of these diamonds basically originate about 150 to 100 or say 200 kilometers, anything between 150 to 200 kilometers below the earth's surface. They form there, and with the volcanic activity through kimberlite pipes or through lamproite pipes, they come to the surface. So by volcanic activity they are brought to the surface. Now why they form at this great depth? Because to convert the carbon into diamond, you need that temperature and a high pressure. The point is that area is called craton. They say that the majority of diamonds are found in the craton, are formed in the craton, which is the thickest part of the earth crust and one of the oldest part of the earth crust. So the question is where these diamonds form, what we are talking about, clipper diamonds. Now why this name has been given clipper to them? They have related these terms C, L, I, etc. to different terminologies. Like say for example, C has been given for Cullinan, a Cullinan-like. They say they are Cullinan-like. What does that mean by Cullinan-like? That means they are generally larger sizes. Cullinan is the largest rough that has been found ever in Africa, which is 3106 carat. Then L has a different meaning, I has a different meaning, P has a different meaning. So let me put it in my words. What does this clipper means? Clipper diamonds are generally, these are type 2A diamonds. That means these are chemically pure, or they call it nitrogen free diamonds. And that's why if you realize, they generally come in a higher color grades. And as you go on a bigger sizes, you will find that most of them, almost 50% of them, they fall into the color D color, which is the best white. They are generally shapeless. Why? The reason is they are in the earth for a very long time, and it takes a long time for their ascent to the surface. And during that ascent, there is all possibility that they are facing a lot of aberration, they are facing a lot of resorb activity. That means their surface is getting reabsorbed by the solutions, by the magma, etc., is reacted upon by the whatever is available around them, and that's why they generally have a relatively smooth surface. The crystallographic faces are generally missing, and that's why they are shapeless. So, in short, these are generally large size diamonds, pure, chemically pure type 2A diamonds. They are generally shapeless or sometimes even fragmented, broken also, and they generally don't have a crystallographic shape. They are resorbed, what they call. That means the surface has been absorbed by the solutions around them. And they generally form anything between 350 to 750 kilometers below the Earth's surface. That means they have a deep mantle origin. They are not formed in the Earth crust. They are forming below that. Or I would say they form somewhere in a transition state between the upper mantle and lower mantle, somewhere say below 600 kilometers below the Earth's surface. Anything more than 600 or 650 kilometers below the Earth's surface, that is where they are forming, and from there they have been brought to the surface. And surprisingly, they turned out to be so special. They are, in most of the time, they are D color, they have excellent clarity, they can also have excellent purity. So these are like a noble diamonds belonging to the certain category, and they have been given the name Clipper diamonds. The question is, what is the reason that they have come to the conclusion that these are from deep mantle origin? Now, if you realize normal diamonds, the regular diamonds, they generally have a typical inclusions, like we have nuts, that is graphite spots, we have colorless crystals, and there are other inclusions which are not from the great depth. But if you realize these inclusions, when they studied these diamonds, when the research was done on these diamonds, they found the majority of these diamonds, Clipper diamonds, they have metallic inclusions, that is the alloy of iron and nickel. They also have iron nickel sulfides also. And these inclusions generally shows a flaky character, and they are generally surrounded by fluid methane and hydrogen. Now these kind of inclusions are generally not found in normal diamonds, and these are the kind of inclusions which are found at a great depth in the earth crust, and it is expected from these inclusions they have come to the conclusion that these diamonds have formed in metallic fluids. So they have crystallized out of the metallic fluid, they have formed there, they have become larger, and then they have been brought to the surface. That is a conclusion which has been drawn. Now, other than the metallic inclusions, like say for example, let me read it for you. Now, this iron nickel sulfides which are there, that is called, that minerals are called pyrrhotite, and then they say that there are iron carbides are also present in these metallic inclusions. Now with these metallic inclusions, they have also found what is called the high pressure silicate minerals, that is calcium silicates have been found in these minerals, and these are basically perovskite. Now perovskite generally forms at a depth anything between 350 to 750 kilometers below the Earth's surface. So the inclusions within these diamonds are proving that the diamonds have a great depth origin. That means they have formed at great depth and then they have been brought to the surface, and their origin of great depth suggests why they are poor in nitrogen, because nitrogen is available mainly near the surface in the earth crust, but as you go deeper and deeper there is no nitrogen available, and that is the reason they are nitrogen free. So this is the basic module that has been suggested by Dr. Ivan Smith and others who have done the research on this field. I hope this topic of clipper diamonds or deep mantle type 2A diamond is quite clear to you. In next video we will talk about the blue diamonds, which also supposed to be having a deep mantle origin, which are type 2B diamonds. Thank you very much.